I'm going to show you something today which I think is very cool. I've over the last couple of weeks implemented a debugger within Visual Studio Code to debug programs that are emulated within OpenMSX. And as a basis, I used a fabulous debugger that was already out there called Dzog for the Spectrum, which contains already a lot of features. Everything that makes you feel immediately at home within Visual Studio Code. So just to show you off what the capabilities are, I thought I'd make this video that tells you a little bit how and what. So what do you see here? You see on the left, you see Visual Studio Code, and on the right, we have OpenMSX. So let's just look at what I've done. So I've actually created a little program that says hello world, but then a little bit different. So it is a MSX-DOS program. It starts at 100. It loads a text called hello MSX. And MSX-DOS always wants to have a $sign at the end. So it calls the str_out function, calls bdos, which is the entry point of an MSX-DOS. And it prints out that text. The next thing what it does, it just loads another text with a new line in it, debugging with Dzog, and it ends with a 0 because I thought it would be cool to have another function that does it a little bit the other way. So it loads every time a character, checks if it's a 0. If it is, it stops. If not, then it just outputs that character to the console, which is the screen in MSX-DOS. And that's what it continuously does. So pretty simple, pretty basic, but it helps us to show off the capabilities of OpenMSX. I don't know what's actually wrong here with OpenMSX, so actually I'm going to force quit it somehow. And it isn't responding anymore. I had it open already for some time. So let's open it again. So this is OpenMSX. So I'm actually loading the Philips NMS 8250 MSX2 image within OpenMSX. And so currently it goes to basic and there's no disk mounted. So what I'm going to do is I'm actually going to point it to the bin directory of this program. So that helps with debugging. So here is the Dezog MSX example. Go to the bin directory, insert this directory as disk. So as you can see, there are already some files, and I put msx-dos.sys and command.com in it so that it helps me to boot it into DOS. Let's just see if that works. So I'm rebooting. And yes, we see it going to MSX-DOS. So that's all cool. So this is just the basics. Let's just look at the setup in Visual Studio Code. So I have an assembly file and I've created a make file. I like to use make files. You can also use the Visual Studio Code tasks, which I will also show you later. But in this case, I created a make file. And I've done two things. So I have here Chasm Plus. So this is my main compiler. And I just, for the fun of it, I also compile my code with Glass. I'm still, by the way, trying to see if I can make Glass compatible with the debugger. But currently I'm using Chasm Plus. And see here is that every time I'm generating something, I'm not only creating a sim file, which is something you maybe are already used to, I'm also going to create a list file. So, and then I have 2 times the instruction to generate it. So hello is made by Chasm Plus and hello G is made by Class. Pretty simple. Now, to make sure that I keep everything honest, I'm going to delete all the files that are in the output directory. And gone. And let's just build it. So I'm just using the build command here. And as you can see, it runs make. Shazam Plus has 0 errors and Glass also doesn't complain. So as a result, I have 2 times a com file. Let's just see what it does. So I type hello MSX, debugging with Dzog, and hello G. Exactly the same, of course, because it's the same program. So this just shows you a little bit in principle how to set up your build environment to work with Shazam Plus or Glass. So let's just delve in a little bit further. So because we want to go debugging, of course. So this is the make file. Let's look at the list file because this is an essential component. So the list file is emitted by Shazam Plus, and what it does, it writes a line number followed with the program address, and then just what it sees in the ASM file, line by line. So every line is represented in the hello list file, as you can see here. So that is what it does, and that helps it, of course, to when you hit a breakpoint, to find the corresponding code back in the debugger. So that's only why it does. So when it hits 0108, it knows to pull up line 12. So if you put vice versa a breakpoint on line 12 in the editor, it knows that it corresponds with 0108. So this is an important thing. So let's just have a look at how you set the Dzog debugger up. So the first thing you do is you install the Dzog package. So I have it currently set up. And just to make it honest, I uninstalled it. So currently the Dzog debugger is uninstalled, and normally you also have to open the Visual Studio Code again. So I'll just do that. So I'm all back. If I go to and ask it to show the installed extensions, then you don't see Dzog anymore. Maybe this is a cool point to also highlight that in developing, I have also installed a couple of additional things that are in Visual Studio Code. So one is the Z80 Macro Assembler. What this does is it provides syntax highlighting for Z80 assembly sources. And also for specific flavors of assemblers like Shazam, Pasmo, TNISM, etc. And it has something built in for what I call problem matchers. So if you get an error message in your output, and as you have seen when I built something, it gave an output, but if it contains an error, then you can just float over it, click on the error, and then it transports you to where you actually made it. I don't know, a typing mistake or whatever. So that's how you do it. You set that up in the task.json. Now, going now to open my sample back up. So here we are. Okay. So now maybe it's good to have a look at the task.json, because maybe here you can see that I have actually set up this so-called problem matcher for Shazam Plus, so that when I get an error, that I can automatically go it. But let's continue with installing Dzog. Now, unfortunately, we're not in the, there is a Dzog in the marketplace. That's here. But that is the one that is only compatible with Spectrum emulators. But this does give you a nice overview of what it all is capable of. Nice animation. On the Spectrum, it even supports sprites and all kinds of other cool things. Most of the features I have managed to move to OpenMSX and Visual Studio Code, but not all of that. So we're still talking about a preliminary release. So let's just go to my GitHub page and download the the Dzog release that I have created. So if you get here, you can go to the release and you can read here. I have a pre-release for OpenMSX. It gives you some instructions on how to set it up. More about that later. But let's download first this file, Dzog132VSIX. You'll find it here, and here it is, downloading. By the way, I'm running this on a Mac, but since Visual Studio Code is platform neutral, you can also do this on a Windows PC, so or a Linux if you want. So I'm going to actually copy paste this instruction, so because I want to run it. So okay, back in Visual Studio Code. So I told you you can install it from the marketplace, but that version does not support OpenMSX. It's version 1.3.1, and I have created a 1.3.2. So I downloaded to my downloads folder. So what I'm going to do is I'm going to paste this instruction in the terminal of Visual Studio Code. And here I'm going to add that I want to install it from my downloads folder. And here it is installing. And it's installed. Again, it is smart to restart Visual Studio Code because then you know for sure everything is set up correctly. So I just do this. And close my browser and start Visual Studio Code again. And the Dezog MSX sample. Okay, so I got my main program. I have my build environment and I can build code. Now I want to debug. So for this, if you saw on the website, there I made mention of a so-called launch.json file. If you start debugging the first time in Visual Studio Code, it asks you how to debug it, which debugger to use. And when you say in this, for example, Dzog, then it already generates a sample launch.json, but it only contains a couple of things, the type Dzog in it, but for the rest not. So you have to add these things to it. Some of these things are still in remarks because I'm still thinking how to support it. So I say, okay, when I launch my debugger, it should actually run the Dzog debugger. But within it, and that is cool with Dzog, it already supported the concept of remotes. So it supports 3 different Spectrum emulators, and I added just OpenMSX to it. And here's an interesting thing. I say it that I have a list file, which is in my bin directory, which is here, hello.list, and that is that list file I told about. And I tell it what is my main ASM file. Okay, so the start automatically is I put still on false, which is a feature actually I still have to investigate. The commands after launch, that is a cool thing. With -e, which says actually execute, you can execute any command that you would otherwise here on the right type in your console. So pretty powerful stuff. You can even have multiple commands here if you want to have a whole string of commands like mounting a disk, inserting a cartridge, all kinds of stuff that you want to do automatically as a start of a debug session. Restart launch, you can put on true or false. So every time you start a debug session, it starts to restart OpenMSX. If you want to make sure you always have a clean slate, I have it down false. I say my root folder is the workspace folder, and my temp dir is where it actually generates disassembly files if it hits a spot that it is not in your code. All right, now let's just see if this all works. So I'm going to put a breakpoint here at line 9. So this is where the start of my program is. So and I'm going to press F5, which is start of the debugger. Now, if you can see here immediately, OpenMSX is breaking, and probably we're in the program counter is at 0B51, just a random place. So I'm going to let it continue to run currently, because remember I put, of course, the breakpoint there already. And now I'm going to start the hello program. And when I do this, it hits the breakpoint. So at this moment, it hits the breakpoint. It knows which file it is, and it is line number 9. And it shows also here nicely breakpoint hit 0, 1, etc. So, and now the cool features is that you, for example, can float over things. So if you have text hello, I want to see what it is. Well, it is HELO MSX. So that is cool. This is all mouse overs. You can do it in every register here. You can do it above every label, etc., etc., etc. Pretty powerful. So that is cool. Also interesting is that you have always a memory dump window here, which in this case shows, for example, where DE is pointing to. Now, DE is now pointing to, I don't know, 80. But if I now would step over the instruction, then DE is now filled with text hello 1. And I can immediately check this because here it is set standing at the start place of memory, hello MSX, ending with a $sign. So let's just step through here. So these are things you can do. Now, it already emits the first line of text. And you see OpenMSX already starting to output it, and then it breaks immediately, so you cannot see that it is completing it. Anyway, let's load HL with text hello 1. And that's what you see here. And you can also check it here with, that you can see here is that it actually stands at the \R\n, which is only to output a new line, and then call print. But now I'm going to use the step into feature. So you can see it jumps into the function, and here it loads in register A the first letter, which is 0D, and it checks if this is if it is 0. Now let's check the 0 flag is not 0 here, NZ, so it does not go end, and it of course saves the HL register because DOS disrupts it otherwise, and we're going to emit a character. We retrieve HL back, we increment it, and we just start all over again. No, I'll just let it run. So here you see on the right, OpenMSX has completed the program. Now, let's do something a little bit more exciting. What if I just wanted to have a breakpoint hit, not every time I add a certain instruction, but every time when, I don't know, I'm outputting the letter D. So as you can see, it is 2 times here, the capital D, in debugging with Dzog. So as you can see here, is that the print function here, it loads the letter A, and here I'm going to test it for 0. So I could actually add another breakpoint here. And instead of having it hit every time, I'm going to put a condition there. So only when A equals 44, hexadecimal 44, hexadecimal 40 is A, 41 is B, 43 is C, and 44 is D. You can look it up in the ASCII table, but you can trust me on that. Okay, you see a little bit different icon here, and you can see expression A is AX44. So let's start it all over again. So I'm starting hello, and yes, the first breakpoint is hit. Now just I let it run and see if it stops at the right place. And yes, it does. And as you can see, and because I'm now going to check HL, HL is pointing to text hello +2. Okay, so it's actually in the second or the third character because it starts at 0. So I'm going to check HL, and yes, it points at 44, and here you see a highlight that it is actually pointing to the letter D. I let it run again, and yeah, it is now highlighting Dzog. So pretty cool stuff. While I'm doing this, actually here in the debug console, you can see also some additional information what I'm doing. So that is maybe interesting also to follow where we are in the process. I'm actually going to work on additional features, which are so-called lock points. That is something that Dzog supports. I don't know if I can make it happen, but then you can just not hit breakpoints, but just you log stuff to the debug console of Visual Studio Code once it hits certain function or certain addresses. So then you don't have to stop really, but you can still follow the progress in your program. So that's pretty cool. Yeah, what else can I do? Maybe it's also interesting while I did this to add a watch expression. Now here you can just say, I want to just see HL up close. You know, it's also there, but if you just want to do this, it's pretty fine to do this here. Do this with A. You can also do it with labels, etc. I think you can also do simple arithmetic in that thing, because that's what Visual Studio Code supports. Other thing is also here is that the memory slots. So you see now currently we're running an MSX2 with 4 pages, of course, and all pointing to RAM. You can also see it which RAM segment it is pointing in the memory mapper. You probably also know I have another project called MSX USB, and there I work with Nextdoor, and I've created my own Nextdoor image, and it is a ROM mapper, and even there it shows me the correct ROM bank that I'm actually currently executing in. So that's also very good. So this is that. You can see a disassembly on the instruction where I am. So it's maybe a proof to see if it is the same code as what I'm running here on the side. And you have the so-called alternate register set, which you can also see here. So so that's pretty cool. Now, the call stack is over here as well. So yeah, let's just step through and see if, for example, these values also change. As you can see, if I call DOS, then HL is suddenly completely different, and I pop it back and I increment it. It's now points to the next one, etc., etc., etc. So just plain and simple, debugging with Dzog with OpenMSX. I've made it so that if you run OpenMSX, you need to have it open before you start the debugging cycle, because it will automatically try to find the so-called socket and connect to it. If it's not open, you see an error message appearing here, telling you that you need to first start OpenMSX before you start the debugging session. So yeah, what's on my list for the future? I want to include, of course, other assemblers if possible, to see if we can also have list files supported. There is an interesting feature in Dzog that, as you can currently see, is that when you running through functions, you can also see -10, -1, -2, which tells you actually, okay, I'm at a certain position, and this was my previous instruction, etc. So in loops, it's sometimes easy to follow that. But there's another option within Dzog is that you can have an alternate color to see which code lines have already been hit. So that is pretty cool, but for that I have to find a way to make it happen also within OpenMSX. Sometimes you need the help of the emulator to do something like that. Now in OpenMSX we have TCL to learn a new trick, so let's see if I can get it going. But at the current stage, it's already pretty capable of doing a lot of stuff. It helps me at least with a lot of debugging, so I can keep everything in my favorite code environment and do the debugging also here and not start the separate OpenMSX debugger. So I'm actually pretty happy with this stage, and I will keep on adding additional features over time. Yeah, and I'm also working with the original author of Dzog called Maziak. I've already contacted him, and he agreed to actually merge it with his next release of Dzog. And after that, you will find it back in the marketplace, which will, of course, considerably help with the ease of installing. But now it's just download it and just do one instruction, and you have it already running. So it's actually pretty simple. Okay. With this, I hope you had fun watching this. I've gave you a couple of examples of to set it up correctly. Yeah, of course, also make sure that you have your make files, etc., correctly set up to generate list files, and then you should be very much capable of doing a lot of other stuff. Oh, before I actually go, maybe this is an interesting thing also, is that in this debug console, um, this debug console has a link with OpenMSX. It's actually, it links also to the console here. And it can do a couple of commands, and you can look it up at the Dzog site, how it's done. But I very much use -e, for example. If I want to see the CPU regs, for example, then I can just ask this command. So it actually is now communicating with OpenMSX and asking that. I don't think it is reset. If I do this, as you can see, OpenMSX is listening and resetting it. So on that last note, I'm going to end this video. Hope you enjoy it. And it automatically hits the breakpoint again. Pretty cool. Thank you very much for watching, and have a good day.